when I talk about zoning, I want you to think permit access lists, because switches in SAN are very, very different than switches in LAN or networking, Ethernet switches. The assumption is that by default, in a SAN switch, no DUB-PN can speak to any other DUB-PN by default based on something that we refer to as the default zone. Now I want to look at that. So what I'm going to do is, before we dive into a whiteboard, I'm going to go to my 5K, and what I'm going to do is I'm going to say show zone, actually I'll say show system default zone, and you'll see here that I should be able to just simply hit enter, and what we're going to see is the output that I want to call our attention to. Notice that there is a system default zone, and that default zone is called default zone, and it is a deny. Now this is what I was talking about when it comes to whitelists and blacklists. So in regular networking, I have a switch, and every VLAN or every port belongs to VLAN 1, and by default, if devices are in the same network, they can communicate with one another, no problem, without me doing anything. All I have to do is hook up the port. It's kind of like plug and play. But when it comes to SAN, the rules are different, because I may have a target that belongs to me and only me, and I do not want anyone else to be able to write to it, because they could corrupt my target, therefore corrupting my data. So in the context of switching, this idea of that default zone translates to the fact that no device connected to any other device should be able to communicate without explicitly assigning a permit process or overriding this default process. Now what I'm going to do is I'm going to implement a zone. But I want to talk about zones, first of all, from the perspective of my whiteboard. Now, zones. Zones allow devices to talk to one another. So let's assume or play like we have the world's smallest SAN fabric, i.e. it's going to be a fabric of one switch. We'll just say this is 5K2. And let's say that I have devices that are connected to both sides of this. And since this is a fabric, it's just a switch of one, these would be in ports connected to F ports. And we already know that the initiator and the target would go through the processes that we just described. So for each of these devices, there will be a floggy, there will be a ploggy. Specifically, I'm talking about ploggy 1. So that's going to be a the floggy from both sides and the ploggy. And we already know that the floggies are going to allow me to build a fabric login database. And the ploggies are going to allow me to build the FCNS database. And we know, since we only have one switch, that 5K2 is the principal switch. So there's a lot of stuff that we already know. But the point here is that even though I take my DUB-PN and I get an FCID from both sides, so I take my DUB-PN and I register with the fabric, and the system is going to give me an FCID. Let's just say, for the sake of argument, 0 by 27001 and 0 by 270002, just to have SCIDs that I can play with. And I know that ultimately this port and this port must connect to one another, which is going to be my ploggy 2, my end-to-end ploggy, and we want to build this communication between in ports. Well, the problem with this is as I said, by default, we have a default zone that is configured, and that default zone has a process of deny, which means all communication between endpoints will be blocked unless I explicitly change or modify that behavior, and I'm going to do that by creating a zone. So when I say zone, the thing that you need to understand is that from here to here, for communication to take place, the zone must allow it. And our zones will be roughly analogous to permit access lists. So from the perspective of this, what I need to do is I need to configure a zone. I do that by specifying a zone name, and I give it a name, whatever that name is. Let's just say pod 1. And I'm going to assign it to a vSAN. In this instance, I have vSAN 1. And that's all I'm going to do right now. We're just going to stick with the veritable basics. So the moment that I have zone 1, then all I'm going to do, I'm going to set this up and I'm going to define members. So I'm going to list the PN of device 1, and I'm going to say member PN of device 2. And because both of these PNs are listed inside of the same zone, the direct outcome here is that these devices will be able to talk to one another, thus allowing me to override this default behavior that we just discussed. So in order to be able to do this, I want to create the zone, but I want to talk about some of the different issues. You're going to find out we're going to have a process called basic zoning and a process referred to as enhanced zoning. We're going to start with basic, and that's pretty much all we're going to deal with. I'll just rudimentarily mention the difference between the two when the time comes. So as we start deploying this, remember this is UCS. So we just need a functional fabric. So at the end of the day, I could just simply remove the default zone and change the default zone to permit, but I don't want to do that. I want to be as specific as possible in this implementation. So what I want to do is I'm going to make a zone. So here I'm going to say zone, name, and I'll give it a name. I'm going to call it pod 1 zone. And I'm going to assign it to vSAN 1. Then all I'm going to do is I'm going to say member, and if I use the content sensitive help here, I could use fiber channel aliases, I could use device aliases. I am going to stick with PWWNs. So I'm going to say PWWN, and all I'm going to do is copy the PWWN of this target into this table. Then what I'm going to do is I want to add another device, member PWWN 20 1A 00 25 B5 01 01 01. Now let's look at this zone. So I'll type show zone. And notice I got my name resolution because of my device aliases. So this is going to tell me that this is going to be the pod 1 target, and this is going to be my pod 1 initiator. Now I can create several other zones, but the point is that this is not doing anything for me. In fact, it is not in use. Even though I have a floggy, so if I come over here and say show floggy database for this target, so pod 1 target has floggied, but there's no indication of that in the zone. So what I need to do is I need to find a way to take this access list, or what is analogous to an access list, and deploy it. So the way that this happens, since I build everything on the basis of vSAN, what I would do is I would group all of my zones that I create for a given vSAN into a superset. And we call that a zone set. So if I come over here and I say config T, and I say zone set name, and I'm going to call it pod, well actually we'll just call it vSAN 1 zone set, so Z set, and I'm going to give it the vSAN of 1. So now all I'm going to do is I'm going to list the zones that I want to be members. So I'm going to say member will be pod 1 underscore zone. If I had created more than one zone in vSAN 1, I would itemize them in this listing. Now when we take a look at this, it's important for us to understand I have a zone, still no indication of use, and I have a zone set, which is just a superset of zones and their associated PWWNs, or whatever value I use here, that is going to list this as permitted. So it's going to say in the zone set for vSAN 1, these two PWWNs, these two PWWNs can talk to one another the moment that this is deployed. Now I'm going to go to 5K2 and I want to illustrate something else. So from the perspective of 5K2, I have no zone, and I come up and if I say show zone set, I have no zone set. Now, this is an issue with the way things function in the process known as basic zoning. In basic zoning, what's going to end up happening, I do my configuration on one device where I create my zones, my superset of zones that is created on the basis of vSAN, and then what I do is once I have that superset, I need to actually distribute that zone set to all of the devices in the fabric that have a domain ID, and I do this in such a fashion that they will be enforced in hardware. Now, this is what we refer to as an active zone set. So in other words, in order to get this zone set to appear and be in use, I need to activate it. Think of it like the zone is an access list. The route map would be referencing several access lists, which would be the equivalent of the zone set, and then applying the zone set would be the equivalent of actually applying the route map referencing the ACLs to a process or to an interface or for whatever purpose it is we want to implement it. So just try to draw it to a corollary based on things that happen in normal networking or Ethernet networking. But keep in mind, we're not doing normal networking. So in this process, what I'm going to do is I'm going to go ahead and I'm going to commit this. So how do I do that? Well, I need to activate that zone set. Now, that zone set doesn't exist here, so I have to do it from 5K1. So from 5K1, all I'm going to do is I'm going to say show zone set so I can get the name. And this is the zone set that I called it, vSAN1 Z set. And I'm going to say zone set, activate, name, vSAN1 zone set in vSAN1. And hit enter. Now what this is going to do is this is going to distribute that zone set. So here I'll have a zone, show zone. Here I'll have a show zone set. And if I go to 5K2, I will not have any of those two values. So from this perspective, show zone knows nothing about it. From this perspective, show zone set, he doesn't know anything about it. However, they both know about the active zone set. Show zone set active and hit enter. And there it is. Now what we see here is this asterisk. We've seen a change. So now I know that PWW21:00:00:24:FF:21:2C:00, which is my pod 1 target, has actually attached to the fabric and is active with the FCID of 0x270000. Now this PWWN for my initiator has not floggied, and I can tell that because there is no asterisk telling me that it has. So in this particular scenario, I have a zone, but the problem is that nothing's going to work until such time that I create this particular initiator. And in order to be able to do that, I'm going to have to build a service profile that is going to reference a boot on SAN architecture. So that's going to be a deviation from what we did in the previous videos. What we're going to do now is we're going to create a service profile, and that service profile is going to reference remote boot. I'll go ahead and tell you a hint, give you a hint. You cannot have a service profile that has local boot and SAN boot together. So it's either one or the other. But from the perspective of implementation, this is all going to come together when we build this service profile inside of our fabric interconnect. And we'll see that it will indeed floggy, which means we'll have a floggy on 5K2, which is the way that I have everything hooked up. And that floggy will be translated via the ploggy 1, to the FCNS. All devices will know about it. We'll see that our device aliases should apply. And we should also see that at that particular juncture, we should have activity in the active zone set. Now, later on in your studies, you may want to explore something referred to as enhanced zoning. I mentioned it previously. In an enhanced zone, what we do is we actually disseminate the information to where all of the info, the zones, the zone set, and the active zone set are actually on all of the devices. It's outside the scope of what I want to do here for UCS, but definitely something that we entertained inside the confines of DCII. So with that being said, I'm going to go ahead and put an end to this video, and then what we're going to do is we're going to bring up the UCSM client, and we're going to build a service profile that's going to use all of this sand fabric that we just built. I'm going to leave everything in vSAN 1 just to keep everything simple. So with that being said, I'm Terry Vinson, and I'd like to thank you for learning data center with me.